love this question, and I think I'm going to answer it the way you want me to. So, when a radioactive material atom decays, what happens to that radiation that comes out of it? The big question we have here is, what type of radiation are we talking about? I'm going to, for simplicity's sake, talk about alpha, beta, and gamma decay. The gammas that are produced, they can interact in three main ways: the Compton scattering, photoelectric effect, and pair production. By the way, a incident photon, that is a gamma. A gamma is a type of photon. In all of these interactions, a fast electron can be produced. These are slightly different because this one here produces a scatter photon at a lower energy than the initial one. Pair production, when you have a high energy gamma that interacts with the nucleus, it can produce both a positron and an electron. The electrons produced in that interaction are going to go on and interact like beta decay. The positron, however, is going to go out and seek an electron because it is the opposite as an electron. And it's going to circle around that electron. They're going to get closer and closer to each other until they meet in the middle and annihilate. They will turn completely into energy, which is in the form of two photons traveling in the opposite direction. For those electrons that are knocked off by those gammas, as well as the betas that are produced in beta decay, they're going to interact in several different ways. One of the really common ways is to interact with the electrons surrounding other atoms. It can cause some of those electrons to get knocked off, like this one here, which those can go on again to interact with other electrons. And then what will happen is one of these outer electrons will decay down into this lower orbital and produce an X-ray. That's how X-rays are produced. Another thing that can happen in high energy electrons is it can go around the nucleus of an atom and it will be redirected because of the positive pull on that electron from the nucleus. This will cause Bremsstrahlung to be produced, and that will go on to interact like gammas. Now, like an electron, alpha particles will also interact with the electrons in the surrounding material, but it will interact with a lot of electrons at the same time because it has a stronger negative charge and it's a much larger molecule. This means that it will also travel a much shorter distance. Imagine a person jumping into a ball pit. They'll be interacting with a lot of balls at one time and slowing down very quickly. So what happens to all of that radiation once it's done all these interactions? Well, all of them are going to basically increase the overall movement and kinetic energy of that substance after it's become completely absorbed, and it will increase the temperature. Those alpha particles, once they've slowed down, they'll turn into helium.